Hey, in this video we'll be talking about the standard template library, the STL, set and map structures. So, in the last video we were talking about the list data structure, and with list we were able to use some of the same functions as with vector. We could push back, push front, and we could access and traverse, visit each of these elements using iterators, this iterator pattern. And so one very important point about iterators is thinking about it like pointers. If you were using a pointer and you were traversing through a list and then you modify the list, there's a chance that that pointer would no longer point to anything valid. Say if you removed the object, like the integer that you were pointing at, that would mean that your pointer makes no more sense. It's invalid. The same thing happens with iterators. So this is a point I need to make, that when you're using iterators, you should expect that you need to be very careful when you are iterating over a container and modifying it while you're iterating. So just keep that in mind. So I wanted to look at another type in the standard template library. For this one, I'm going to include set. So a set from this library is very similar to a mathematical set. When you think of a set of numbers, you could think of the set of numbers 1, 2, 3, and 4. These are unique elements in that set. If I took a set of 1, 2, 3, and 4 and I added maybe added another 3 in there, the set would still be the set of 1, 2, 3, and 4. It's more like a class of values. So the same thing works here, and that makes this set type very useful for keeping track of unique entries and like collections. If you want to make sure that you have at least one of something, like that you've collected in a game or something. So here's my set dot, and you'll notice looking through here we don't have push back or push front. We cannot access, we cannot add stuff to the set that way. We have to use insert, and that's because it's not necessarily in any particular order. We should imagine that it's treated like a mathematical set. There's no strict ordering to it, and it doesn't matter what the order is. Whatever we put in, we're not really interested in the order that we put it in. So if I insert just a bunch of different values, here we are, I can still, using iterators, walk through this whole set. So set of integers has an iterator type, my set begin, go until my set dot end. There we go. And I can print out that value. So it may very well be that I get the exact same order that I put them in, but that is not guaranteed unless the specification for this type says so, right? Okay. What did I get? Am I still on the list one? Yeah, I'm still on list. Okay, let me activate this, set a startup project. There we are. Okay, 1, 2, 5, 8. Those are definitely not in the order I inserted them. They look like they're in ascending order, like they've been sorted automatically, which is pretty cool. This is a pretty handy feature of set, that the way that it keeps track of unique values means it sorts them as well. It sorts them and makes so that it's easier to check if there's already one existing in there. So if I insert my set dot insert, let's say another 2, run that. Still, there's only 4 elements. That 2 is a duplicate, so it isn't actually added. Alright, so one of the other things you can do with a set is check to see if it contains a particular value. So my set dot find. So find, this is starting to look really gross in the tips here for how to use this function. There's a lot of this garbage that you're going to have to ignore in order to figure out what find actually does. I'm going to look for the name find in this hint. It's right here. Everything to the left of it is the return type. So it's returning a standard tree set traits using, oh man, yeah, it's kind of crazy stuff. So it's really hard to know what exactly that's saying. But it is saying const iterator at the end. It is returning an iterator. So essentially it's looking for my value, the value that I want to find. So let's try to find 8. And it will return an iterator pointing at that 8 if it finds it. So let's say set of integers, iterator, F. Alright, so now if it did find it, this iterator is pointing there. So I can say, I can check to see if it's valid. If it found it, then it's the iterator pointing at 8. If it did not find it, then it returns the ending iterator. So my set.end, I can check for that. If f does not equal my set.end, then I can say found 8. Alright, otherwise, else did not find 8. And I can do all this over again and try to find another value. Let's see, 167. I don't think that's in there. There we go. Cool. So that's how you can tell if an element is in that set. 8 is in the set, 167 is not. And so you can do this because this is a templated type. You can do that with any type of object. You can do it with strings and whatever. Very powerful stuff. So let me show you one other type, also very powerful, and also might be a little familiar to you. I'm going to include the map header. So a map is an associative array, and you may have heard this term before. When I create a map, I have to choose 2 types. So maybe I want a string mapped to an integer. And this might start looking familiar. In C#, this is a dictionary. So it takes one type on the left and it maps it to another type. And so you can store using mymap.insert. We kind of have to use make pair in order to make a pair of a string, hello, and an integer. In this case, those are what I chose. And then when I want to do other things with this dictionary, I can find elements in it and get an iterator, or I can traverse through the entire data structure and look at all of the things that I've put in there. So let me put in a couple more values here. And then I'll iterate through them. So now this is starting to get really much more annoying to type these iterator types. So instead, I'm going to let the compiler figure it out. Because I'm going to be using mymap.begin to get the beginning iterator, mymap.begin, technically C++ knows what type this is going to return. It's going to return an iterator of this map type. So I can use this auto keyword, and that tells the compiler, you figure it out. You know what to expect. So you can make this type fit what's on the right hand side of the assignment. I'm going to go until we get to mymap.end. And then I want to print these things out. So print out, let's see, this is a little different because when I dereference E, I get the pair that I added, this pair of a string and an integer. So pairs have a first element and a second element, like that. So the first one is going to be a string and the second one is going to be an integer. This syntax is a little messy, dereferencing first and then dot and then the member. You can use the same syntax as with pointers, E arrow first and E arrow second, which is dereferencing and accessing a member with one operator. So that looks a little cleaner. Okay, so now let me try that out. Cool. Alright, prints out all of those. You can also find in much the same way that you do with a set. And this is kind of the power of these two structures here, sets and maps. They are built internally as trees, and trees are amazing at searching. If you were searching through a vector, an array, or a linked list, it would take you a long time to get to the end and find out that your element wasn't there, that your value is not stored there. Or if you have a really big linked list or vector that's got tons of elements, like 1 million elements, it will take a long time just to get to the element you're trying to find, even if it does exist in there. For a map or a set, this is much, much faster. They can skip processing a whole lot of those elements because of the way it's stored and structured internally as a tree data structure. And we won't go into discussing trees and how those are set up, but that's an important topic in our algorithms and data structures course. Okay, for now, this is how you use these standard template library types, and I hope you play around with these, practice them, try to solve some of the problems you may have used dictionary for in the past. See you later.